Welcome back. Today we're going to continue our conversation on finding the nth roots of things. However, today our focus is going to switch a little bit. Instead of everything working out perfectly, pulling out of the radicals, today we're going to deal with things where what happens if they don't? What happens when things don't make nice radicals? So, let's dive right in. Oh, sorry. And again, if you need to go back and look at our step-by-step process, I do have it all written out right here. Otherwise, everything that I say is going to be exactly the same as what is in those set of instructions. That's for you to reflect with later, just in case you lose track of what you're doing or what step you're on. So, square root of 75. We want to simplify this. Now, I go to my chart, okay, and I'm dealing with a square root, so I know I'm in this column right here. However, this time I don't see a 75 on my list anywhere, okay? So that's kind of a dilemma. We haven't hit that yet in this class. I know you learned it back in Expo, but we haven't done it yet this year. So what's going to end up happening is if you don't find that number on the list, what you want to do is you want to find what number on that list divides the number you're talking about. Okay, so I'm going to take that 75, and I'm going to take 75 and I'm going to divide it by 4. Well, I don't get a whole number, so that means that one's not going to work. Okay, 4 is not what I'm looking for. Take 75, divide it by 9. Again, not a whole number, not what I'm looking for. Divided by 16, you don't get a whole number. The first time you get a whole number is when you divide it by 25. 75 divided by 25 gives you 3. So now I found what I needed, okay? That is what I wanted. I wanted to know, how does it split up? And it splits up into 25 and 3. Once I have it split up like that, now I actually know what the square root of 25 is, okay? The square root of 25, according to my chart, is 5. And so I can break it down just like that. Now, this also applies to higher powers, okay? So, this 24, I'm dealing with a cubed root. So, 24, I go to that column of my chart. So now I'm over here. And again, the problem I'm running into is 24 isn't actually on that list. So what do? Well, I start looking at the list for a number that divides 24. And here I actually hit the jackpot right away. 24 divided by 8 gives me a whole number, okay? It gives me 3. So that's how I'm going to break that one down. I split this up into the cubed root of 8, cubed root of 3. Okay? Now, something you do want to know, because we do have a variable in this one, is that this is an odd index, so we don't have to worry about absolute values. Okay, remember that's always in the back of our minds when we're dealing with variables. And now, of course, I know what the cube root of 8 is. My chart told me that the cube root of 8 is 2. Okay, and then of course I have the cube root of 3 that isn't coming out. And then x cubed. Well, how many times does 3 go into 3? Well, it goes in there once. So it pulls out very nicely out front and just is sitting there as an x. And again, it was an odd index, so I don't have to worry about absolute value this time. Let's move on to our next one. This one is even. So now I do have to worry about that absolute value. After I take care of pulling everything out that I can, I'm going to slap the absolute value on and see where is it needed, where is it not needed. Okay. So this time we're dealing with a fourth root and with 32. So I'm going to go to my chart. Fourth root, I'm dealing with this column. And again, now I'm searching. 32 is not on that list, but I'm going to find something that divides 32. And right away, again, I've hit the jackpot. 32 divided by 16 leaves me with 2. So this is going to split up into 16 and 2. Fourth root of 16, fourth root of 2. And the fourth root of 16, if you look, in case you've forgotten that one, The fourth root of 16 is 2. So that simplifies to just 2. And then, of course, the fourth root of 2 is still stuck in there. How many times does 4 go into 8? 4 goes into 8 twice, so that comes out as an x squared. And 4 goes into 12 3 times, so that comes out as a y to the third. Now, of course, we're dealing with an even root, so let's talk about absolute value now. Of course, the 2 doesn't have to stay. A number will never stay inside the square root. And if you look at the x squared, if you square something, it's automatically going to be positive. I don't need to worry about that ever being negative, so it doesn't need an absolute value. The only thing that actually needs it is the y to the third, because that could potentially be a negative value, which is something we don't want to allow to happen. And then the fourth root of 2 just stays chilling on the outside. So that's how we deal with all nice numbers and radicals. But let's talk about the variables now. So we can also run into where the variable won't pull out nicely. Okay? So if you look at this, a square root. Well, in this case, 2 doesn't go into 5, does it? So this is not going to come out completely nicely. Now, before I go too far, I try to emphasize the first thing you always want to do, label this as even. That means we know we're going to deal with the absolute value later on. But let's get back to talking about the fact it's not going to be a nice value. 2 doesn't go into 5 nicely. Okay, so now I need to look to see how many times can 2 go into 5 without going over. Okay, and what ends up happening is 2 goes in there twice. 2 times 2 is 4. Now what that means is how many more do I need? Well, 4 to get up to 5, it means I have 1 left over, 1 that I haven't used yet, and that is going to stay inside the radical. Okay, so you see how many times can you put it in completely, how many times can I put it in nicely? The leftovers have to stay inside the radical. Okay, so of course it's even, so anything I pulled out, I need to slap the absolute value on. However, x squared, if you're squaring something, taking it to an even power, it'll never be negative anyway. So you can actually end up removing the absolute value, and you want to leave it looking just like that. So that's the basis of this, but let's keep going just to make sure that you feel comfortable with it. So this is an odd one, so I don't have to worry about absolute value this time. You're welcome. Now we're looking at cube root, and we have negative 125. So remember, for odd roots, it's okay to have a negative inside, so we don't have to be concerned with that. Looking under third power, 25 is just the number 5. That's actually a nice one that is on our list. So the number is going to pull out as just negative 5. Okay, nice and simple. Now let's take a look at this. How many times can 3 go into 7? Well, completely, 3 can go into 7 twice, right? So it's going to pull out y squared because 3 goes in there completely twice. But that only takes us up to 6. So that means we have 1 more to get us up to 7. 1 more that can't pull out. And so that 1 is still going to be stuck inside the radical. And again, in this case, because we're dealing with an odd index, it means we don't have to be concerned with absolute values. And moving to our next one, a fourth power is even. So unfortunately, that does mean we are going to have to deal with absolute value at the end here. My number, 625. Whenever you're looking at a number, you should be looking at your chart. We're dealing with a fourth root, so I'm going to focus on this column right here. I tried to be kind again, and look, 625 is on your list. It is the number 5. So that's going to come out nicely as 5. And now let's look. 4 goes into 4 once. So that's just going to pull as an x to the first, but of course I don't have to actually show the first. 4 going into 10 now. Well, 4 goes into 10 twice. Okay, so that's going to come out as a y squared. 4 times 2, that got me up to 8. Okay, pulling out 2 4s is actually pulling out 8. So to get up to 10, that means I still have 2 left. Okay, 2 left that didn't come out. Oh, not x, I apologize. So that means I have a y squared left over. Y squared that does not get to pull out. Okay, and of course, we're talking about an even index. Let's analyze with absolute value. The 5 can come out. A 5 never has to remain inside an absolute value. Y squared, any even power, doesn't need it. The only thing that does is that x. That x could be negative. And then I write that, and now I'm done with my problem. So I don't think it's too particularly difficult as long as you're very good at maneuvering that powers chart, maneuvering the table, and you can figure out how many times can things go into other numbers, okay, to deal with those exponents well. Let's move on to the next page. So let's start putting these skills completely together, okay? I was nice at first having you only focus on unnice numbers or unnice roots. Now I'm going to kind of start throwing them all together at you, okay? Because on your practice work and on your test, you're going to have to juggle both of these skills at the same time. So the first thing I always do is I'm going to focus on the number piece, okay? And notice that little note I left for you there that the negative always comes out. Don't leave the negative in the root for an odd one. Always pull it out. That's considered more simplified. Now, you should remember that from quadratics, that I said never, ever, ever leave a negative inside of a root. Still applies in this chapter. So we're dealing with a third root. So I'm going to be dealing with this column. And now let's see which one divides 54. 54 divided by 8. That does not turn out to be a nice number, so that is not what I'm looking for. 54 divided by 27. There is our jackpot. We want 27. 27 times what? Well, your calculator should have told you 2. So the first thing I'm going to do is I'm going to split this up into 27 and 2. And I'm sorry, I'm getting ahead of myself. I do always want you to note this is odd, which means I do not need absolute value. Okay, if you get in the habit of labeling that, it's going to make your life so much easier come test time, so you won't forget when and when not to use absolute value. All right, so cubed root of 27. Well, we know that it's the number 3, and I'm sorry, I forgot. I really should have put that negative with a 27. Okay, remember that negative is going to pull out with the nice piece of the number. Okay, so that's going to be a negative 3 sitting on the outside, and then a 2 there. Now notice I left some space because I know I'm going to be pulling out some variables and stuff like that. So when I break down the number, I'm just in a habit. I leave some space in between the two pieces so I can include things as they're coming in and out of the radical. Now let's focus on the variables. 3 goes into 6 twice nicely. Okay, so the x actually completely pulls out nicely. However, the y, not so much. 3 goes into 8, not an even amount of times. 3 goes into 8 twice, but that only gets me up to 6. So that means to get me up to 8, there's 2 more in there that can't pull out. So I'm going to leave it looking like that. And again, because it was an odd index, don't need to worry about absolute value. So that's actually the end of that problem. Let's look at the next one. So here I'm dealing with the 4th power, which is even. So that means ultimately I am going to be dealing with absolute value in the end. But let's take a look at that number, 48. So I'm going to go to my power chart, dealing with 4th power. So I'm going to start dividing 48 by each number down the list until I get the one that I want. Now this one I was kind with the first number you pick actually ends up working. 48 divided by 16 leaves you with 3. So I'm going to split this up into the fourth root of 16 and the fourth root of 3. Okay? Always break down the number piece first. Fourth root of 16, in case you've forgotten, drag it over, is going to be the number 2. So this becomes 2, and then I have the 3 still left inside. I'm going to leave myself some space to work because now I have to start looking at the variables. So let's look at the x's. How many times does 4 go into 5? Well, 4 goes into 5 once completely, so I put an x to the first out there. But now that only leaves me at 4. I need to get up to 5. So that means I have 1 left over that stays inside the radical. What about the y's? 4 goes into 9 twice. Okay, 4 times 2 gets me up to 8, but I need to get up to 9. So that means I have 1 more that's going to be left over that's going to be stuck back inside the radical that can't leave. And of course, this was an even index, so I'm going to put the absolute value signs on. And now I'm going to analyze what actually needs to be in there and what doesn't need to be in there. A number never does. Something to an even power never does. So the only thing that's really stuck is the x, okay? So the x is stuck inside. Now, of course, the rest of it just stays there behind it. Let's take a look at our last one. So here we're dealing with a fifth root. Okay, so this is odd. And now, let's go look at our chart. So they're dealing with the fifth root, 243. Well, I was nice. That actually is on the list. So we don't even have to break it up. It just actually is the number 3. So that's really nice when that happens, okay? When you get actually a number that just completely pulls out. So right now, I have nothing that's stuck in the radical, okay? Just because that number completely came out. Let's look at the other pieces. How many times does 5 go into 10? Well, twice. Now, here's a situation. Can 5 go into 2? Well, no, because 5 is already bigger than 2. So here, that y squared actually can't break down. It can't actually do anything. That is going to be completely stuck inside. If the variable has an exponent smaller than the index, it doesn't do anything. It just stays inside, okay? And I even left you a little note to remind you of that. So as you're studying or reflecting on this, you have those little mental notes along the way to look at. Because the index was odd, we don't have to deal with the absolute value. So this actually is the end of our problem. All right, so some really good stuff in here. So what I want you to do, I want you to write your summary now. I've modeled one for you, so now it's your turn. After you've watched this video, right after, now I want you to stop and write that summary for me. Either describe how you're going to remember these skills or what you learned that was new, something interesting, a question you still have, anything along those lines. I do want you to write down, and so you can reflect on it before the test or you know what you want to ask me. So again, please take a moment, write out that summary, and then come back to class ready to do your practice work.